Anyway, welcome everybody to Introduction to Iterators. The disclaimer being, again, it's just an introduction. There are a lot more details I'm not going to cover, but hopefully this is just enough to give you a broad overview of what iterators are, when you might want to use them, and how you might create them. Okay, what is an iterator? An iterator is basically an interface to a list. It contains and or generates the list, usually generating most of the time, but you can, if you want, contain it. And an iterator also contains state information about the current position you are in the list. So it's basically, if you had an object, let's say, that had a next method, you could say object arrow next, and it would give you the next value. And then the next call, if this were in a while loop, it's keeping state information so it knows how to get the next value for you. Now that value may exist, it may be calculated, it just depends on what your iterator is doing and as to how it comes up with what the next value is. Okay, why would you want to do such a thing? Well, let's say you had a large or an infinite list. One of the examples while I was doing research for putting this together was, say you wanted to have some sort of interface to the Unix yes command. Well, if you tried to, let's say, open a pipe to it and stick it in an array, guess what happens? All sorts of fun, yes, exactly. It's going to go boom once you run out of memory. So, but if you created an iterator interface, then it will very happily say yes, 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 as many times as you want. So who needs yes men anymore? You can just replace them with a program. But that brings up an interesting point too, that you may want to just arbitrarily stop after it's told you yes 10 times. I don't know why, but let's just say you only wanted 10 yeses. Well, if it were an infinite list, how do you get 10 out of an infinite list? But in this case, you can with an iterator because you just tell it to stop once you've got 10. You might have something like a circular list that repeats itself, which again, basically gives you an infinite list sort of situation if you keep cycling around, but you could tell it to stop at any arbitrary point that you decide you wanted to stop at. Let's say instead of having yes, yes, yes over and over, let's just say it's a very large list, but you may only need a few values out of it. So you definitely don't want to load the whole thing into memory at once just to go in and grab 5 values out of it. And let's say the list is 1,000 pieces of data long. It doesn't make much sense to load that whole thing into memory at once. If you have several different functions that want to operate on the list, like if you're, let's say, parsing through a config file format of some kind, where let's say you've got headers and then you've got config information. Well, you could have one function that handles the headers and another function that handles the individual pieces of configuration. With an iterator, since you remember it keeps track of where it's at, you can pass it around to different functions, and different functions can do different things with it, and then realize, oh, this is a header, I pass it back to the header handling part of the function. Or, oh, this is config data, so I pass it to the config data handling part of the program. One other thing, which actually I didn't see mentioned anywhere, but actually the main reason why I bothered writing iterators is a common interface. Because basically I have a situation where I've got, I want a table of data where I've got rows which hold cells of objects that are cells that hold values in them. But I may want to have iterators that can handle all kinds of different data sources. One of them might be a statement handle from DBI, One of them might be, sometimes you get stuck and maybe it's not your choice, but maybe you've already got it all in memory. But now you can just wrap a little bit of code around it, turn it into an iterator, and it will give you a common interface to this. Because you remember the interface is fairly simple. It's next. And it gives you whatever that means. So you kind of have to know, though, in your program, what the iterator is going to give you, obviously. You can't treat it like a black box because it may be returning a single object. It may be returning an array reference. It may return multiple values if you set it up that way. It may return hash ref, whatever. There's a bunch of different things it can return. So you kind of have to know when you're doing that. But usually, as you'll see once we start going through this, that's really not that much of a problem. Any questions so far? Okay, here are some common iterators which you probably use all the time in Perl and maybe don't think about it a lot. File handle. What happens if you use a, file handle in angle brackets in a while loop? It just gives you one line at a time as you're going through it. That's if it's in scalar context. If it's in array context or list context, it's going to give them all at once. But in scalar context, it's going to just act as an iterator. And it doesn't load the whole file into memory, because this file may be huge. It just gives you just the next line. And again, it's got state information that keeps track of where was I at, what is the next record that I need to give. So dir handles or directory handles, again, same thing. Hashes. If you use each on them, you remember each gives you back the key and the value. So that's an example where I said earlier, you may actually return more than one value. Well, that's an example of one that does. But obviously you know that because you read the documentation on each, and so each returns a key and a value. And again, in scalar context, if you're in a list, it's just going to give you one at a time, right? So, regular expressions, also, if you're using them in a scalar context with a G flag on the end, that will, which again is global, so it means you may find multiple matches within this string, but in a scalar context, it's going to treat it like an iterator. It's just going to give you one. There may be 10 matches, but it's just going to give them to you one at a time. Not all of them at once. Again, if you put it in array context, it'll give them to you all at once happily, but in scalar context, it acts as an iterator. And statement handles from DBI with the example of fetch row array ref just being one that I arbitrarily picked. Obviously, it does what it says it does. It fetches one row and returns it as an array ref. So, any questions there so far? I could have come up with other examples, but these are probably some of the most common ones that a lot of you, if not all of you, have seen. Okay, now we'll actually look at an example of an iterator. Okay, up here, again, not that much interesting. We're using DBI, SQLite database, creating our DBI object, selecting all from our contact table, which has 3 tables, ID, first name, last name, executing, and then boom, now we're hitting VS Iterator new. So this is where we're creating our iterator. So now I'm going to walk you through how this actually works. All right, I've got a parameter which is a reference to a function, SQL Iterator Factory, which we'll look at that. That's pretty much the meat of this. And then right here, iterator args are any arguments you want to pass to the iterator that you create. Well, since I'm using a statement handle, I better give that to the iterator so it has something to give me back when I ask for things. So for right now, we're going to skip all of this stuff because this has more to do with overloading. And now we're going to look at Iterator Factory. Okay, basically I'm just pulling in table row because it just so happens that that's the type of thing I want my iterator to return. Again, I said it could be an object, could be multiple values, could be arrayref, hashref, whatever. A lot of different things it could be. So you notice here, my statement handle, I'm setting to args statement handle, because again, that's how I passed it in into the Iterator Factory. Here's my actual iterator. It's an anonymous subroutine, right? So this is going to, Iterator will now hold a reference to this anonymous subroutine. And then basically my data is just saying fetch row arrayref. You remember that's why I used that example earlier, which is just going to give me an array reference of whatever my SQL was doing, which you remember was select star from contact. Okay. Now I'm going to return undef unless data. I know some people really hate unless. I'm kind of on the fence. Sometimes it works, sometimes it doesn't. I thought it worked here. So basically, if I have no data, I'm going to return undef. Now, I'm going to just briefly digress. This is actually a huge topic in iterators, and there's a lot that could be said about it, but I don't have time, so we're not going to do that. But basically, the value that you return to indicate that your iterator is done, or exhausted as they usually call it, you have to put some thought into what that is, depending on what you're doing. Here it happens to be fairly simple though, because the data that I'm returning, if I've got data, is an array ref, right? Well, undef is a scalar value. So it's pretty easy for, like, say, a while loop to decide, oh, hey, I'm done. I got an undef back, so I'm finished. In other cases, you may run into cases where it's not so simple to pick something, like if you were returning scalars, what if undef was a valid value within the list of things you're returning? Then you have to put some more thought into it. But again, not going to get into it. I'm just going to point out that that's an issue you may have to put some thought into, returning a special value and capturing that and somehow indicating, to yourself or the user of your iterator, hey, I'm done, I'm finished. One of the iterator objects I saw in CPAN did it by actually kind of cheating and actually buffering a value. So when you asked for next, you were actually asking for the previous value, because it was, as soon as you created it, it grabbed the next value, buffered it, and then when you said next, it would give you this one and then stick another one in the buffer. That way, you're kind of, the iterator is looking one ahead, so it can actually tell when it's done, and so then you can actually have a method that you can query and say, hey, are you done? Well, guess what? This time it knows because it's already fetched the next value. The way I'm implementing it, though, that doesn't work because I don't actually know what the next value is until I actually fetch it, because I'm not looking ahead. So anyway, just a little digression there as to some of the issues that you might have to think about. But for simple things like what I'm doing here, undef works really great. So field names, you remember when we talked earlier about the row, you can pass in field names, which I get from the statement handle by asking for name lowercase. I just so happens I want them to be lowercase. I could have done uppercase or whatever. But in my case, I just prefer to get the lowercase. And so then I create my table object. I pass it data, which you remember we got an array ref. Pass it a row number, which I'm just incrementing, just starts at 0 and counts up. And then the field names, which we also got from the statement handle, because it knows some metadata about the data it just returned. So far, so good? Okay. And then we return the actual row object. And then we have, maybe somewhat confusingly down here, another return, iterator. That's because Iterator Factory, when you actually call it, what it does is it creates this, create with quotes, this anonymous subroutine, and then returns it. So this actually acts as a factory or to create the iterator for you. So again, it's not going to do the iterating, it's going to create the iterator for you, and then you use it to iterate through. Is that distinction clear to everybody? Okay. All right. Okay. If we have no more questions there, we'll actually look at another example here. And this, again, is just to give you an idea of why I wanted a common interface. This is basically a file system iterator. A little oversimplified for this example, but it gives you the idea. Basically, all of this stuff looks normal. Some of you guys may have heard me talk about IO_all before. Basically, all you need to know about IO_all for the purposes of this is it's just kind of a nice interface / wrapper around a whole bunch of Perl IO modules, so it allows you to have access to all kinds of different IO things. Mostly what I wanted to do is just return file names in this example, so not doing anything too fancy with it. But basically you pass in whatever your first argument is on the command line, it uses that as a directory name, and then it goes and lists things out of that directory. So again, we're Iterator Factory and the args. Again, we're passing in the IO object because that's what the iterator is going to need. And then this is the factory. I'm getting in my args. I'm setting it to IO just for convenience sake. All I do is I say IO return next. Okay? Then again, you remember this is the factory that creates the iterator, so this actually returns the iterator. Now, I kind of skipped by this in the last example because I wanted to pick this one as a simpler example so you could see directly what's going on. Here is the actual iteration that's going on. So now, you remember the iterator we created, which is this anonymous subroutine, gets returned back into FS iterator. Everybody understand that so far? Okay. So, now again, in my list, it just so happens that IO_all, when you're calling its next, returns undef when it's done. So that works transparently for me. I don't even have to do anything with it. I just, pass it on through. And so I just say IO FS iterator next. Every time that I call next, it's going to call IO's next and return that IO object, which is basically going to be a file object or a directory object, depending on what it is, as it's iterating through the directory that I pass it, because that's what next does for IO. But sure.
So on the IO object, it needs to implement next.
Well, no, it's just it's coincidental that it does next.
Right.
But
I'm saying if you didn't do it that way, then you have to define.
Well, no, if this were not next, it would be something else like next directory entry or something. Let's say it was something horrible like that.
Right, but then you would define that as your next subroutine, or
well, no, simply.
Interface, right?
Well, yeah, I'm going to get to, I know that's the part you're going to have to wait just a little bit longer on, because I'm going to show you how, because I haven't really talked about how the object here gets created. We've talked about the factory, we've talked about the iterator you get back, then we're going to talk about how do you actually get that in the middle. So I'm going to get to that in just a little bit. No, that's fine, that's fine. So does anybody, and then all I ask it for is its file name, and it, just gives it back. We'll just do a little example here. We'll just ask it to list current directory. I know the font's kind of small, but just trust me, this is the directory contents. One thing I will point out, though, is they are not sorted. They're not in alphabetical order. We'll talk more about that later. All right, any questions about this so far? We're about to get to the part where it brings it all together. This array iterator, I'm going to kind of skim over this because really it's doing the same thing, the IO, but instead of next, I'm calling all on it to deliberately give me everything back. This is I'm simulating an example where you may have everything already as a full list. You've got it all contained in memory, but you still want to treat it like it's an iterator, and you only want to get one value at a time. This is obviously not an ideal case, and you wouldn't want to do this because it's kind of defeats most of the purpose of having an iterator. But sometimes you're not always given the choice of the data source that you're getting. So I just wanted to give an example of, well, if you already have everything in memory, you can still give it a common interface by turning it into an iterator, and then you can pretend that it's not all in memory if you want, but that way you can treat different things with the same interface just by calling next and getting something back. So anyway, that one again, not too interesting. We'll pass most of that up. All right, the example of the code, which actually I failed to make a slide for. Yay me. Hang on just a second. We'll fix that. Okay, good. I'll fix this by the time I get the slides up on the internet. And we will maximize this. See. Does that look reasonable to everybody? Okay. All right. Just doing normal stuff here, defining my package, warning stricts, carp, setting the version, nothing that interesting here. New, nothing we haven't seen before. Here, I'm just in my initialize, I'm setting up a few mutators. Again, there are different ways of doing this. You can do them by hand. This is just the way I've been doing them for a long time. Now, right here in initialize, this is the important part. This is where I'm actually creating the iterator, because I'm calling self Iterator Factory, and then you remember that's an anonymous subroutine, right? So think of this all as if it were a subroutine name. Then anything in the parentheses are the arguments that go to that subroutine. Just so happens in this case it doesn't have a name, it's anonymous. So we pass it, again, the args, which you remember is a hash ref, separate hash ref that we pass into it. That's where you can pass in your data source, your statement handle, or your IO object, or your directory handle, or file handle, or whatever. That's how you can pass it in. I'm gonna skim over this. All right, this is it. This gets to, I think, the point you were asking, Brian, and correct me if this doesn't answer it. All right, what this does, this is more or less just kind of syntactic sugar on top of just calling it, instead of calling it this way, which is what you'd normally do, because again, it's an anonymous subroutine, I'm just using next as a nice wrapper, because next is a little more self-documenting when you see it, rather than this. Wouldn't most of you agree you'd prefer to see iterator arrow next rather than iterator arrow empty parentheses? That's mostly why. And then guess what this returns? The actual next value, which in the IO case was an IO object, a file object, or a directory object when we got our listing. Or in the database case, it was the actual array reference that you get back from the statement handle, and that's what you operate on next. So, any questions there? That's basically all there is to it. And again, you don't even have to wrap this in an object. If you read about iterators, there's plenty of ways you can do it without even bringing objects into it. Just so happened that because I wanted to use next, more or less I decided I wanted to wrap it in an object. I also figured down the line I may want to put more into it than what it's got now. But right now, that's all it does, is pulls in some arguments, uses the factory function that you passed it to create an iterator, and then provides an interface called next for you to call the iterator and return the next value. Any questions? All right. Well, thanks very much for coming.
One question is, how much
Sure.
do you use that like for each? Can you make an iterator that works with for each?
Basically, for each expects a list. So you could iterate, stuff it in a list, and then use it in for each. But I don't know, any ideas off the top of your head?
Context for it.
Yeah.
So if you wanted to go full madness, you could overload angle bracket to next.
Yes, yes. Actually, I'm glad you brought that up because I did think about that. Yes.
Well, I guess that's my point. I wanted to know how do you overload and use iterators at the same time.
Well, yeah, that's how you could do it, is you could basically treat the object as if it were a file handle, only really it's not. It returns objects, yes, because you can do that with basically using the overload part with the angle brackets. Yes, you can definitely do
Put that
it.
in while, and the topic variable would be the current object
Yes.
out of the iterator.
So, and again, if you may not remember, the topic variable is $_. So that's, yeah. So yeah, you can do.
Overload video.
Yes. And also, I see, it's hard for me to split these, John. I just can't do it. Because now I'm going to go back to the first talk. One of the things I should have said earlier, too, is you should use discretion when using overloading. Some people go nuts with it and use it in cases where it doesn't make very much sense. Sometimes it can actually be more confusing than enlightening. But like another good example of overloading, I would argue would be, I don't remember the module's exact name, but it's giving you objects that are complex numbers. So any of you that remember your imaginary numbers where you've got a real component and an imaginary component. Well, you can overload, the normal operators so that it can take those objects that are actually holding two components, a real and an imaginary, and then you can actually do your normal mathematical operations on it. That kind of makes sense, right? Whereas if you just, randomly took, well, if you like overloaded plus to, concatenate or something, well, you'd really blow people's mind. Or otherwise known as, JavaScript or
We
something.
talked about, we could overload angle bracket in here, and that's kind of cute. But the next step past cute is madness.
And if you look at that IO all, it actually does a lot with overloading, so that like the left shift operator and the right shift operator, which are the double brackets, turn into print and
Oh,
turn
like C++?
right.
Yeah, exactly. It is like C++. Which, yeah, I mean, some people, I'll admit, some people hate IOL, but I actually like it, and I don't mind that syntax because, I don't know, it's one of those things that if you're using IOL, I guess you should expect that syntax if you read the docs. So,
Most of it is pretty well optional.
Yeah, exactly. Yeah, and there are actually methods you can use instead of using the operator overloading. You can say IO print, to print things. I'm doing this off the top of my head, so it may not be exactly like that, but there are methods that you can call to do the similar sorts of things if you'd rather do it the object-oriented way rather than the operator overloading way. So, all right, any more questions? Yes.
You said something about sort. I don't know if you.
Oh, no, I didn't. Good point. Thank you for calling me on that. Yeah, the reason is because, guess what? We're only getting one thing at a time with an iterator. In the array one that I kind of breezed through, since I asked it for everything, by default, IO all actually does sort the things back, so that you'll get them back sorted. Or if it didn't, you could sort them yourself with the list. But with the iterator, since you're only getting one at a time, you can't really sort them, without doing some sort of buffering or something. But then again, you're getting away from the point of an iterator, because then you're starting to load everything into memory at once. So that was just to show you that there are some possibly downsides to it, to using an iterator. So keep that kind of thing in mind, that it may not work out so well if you really, really need everything sorted. Or you could just run the iterator, load it into a list and, an array, and then sort the array if you want. That sort of thing. But, just keep that in mind. It's not a silver bullet that solves all problems. It's just there are certain cases where it's really handy to use. So, all right. Anything else? All right. Well, I hope you all enjoyed it and maybe learned a thing or two. Thanks for coming.